Okay, so today I want to talk to you guys about forces and Newton's laws. So the first thing here is just talking about the definition of a force. A force is simply just a push or a pull. Hopefully, you guys understand that you do have natural forces out there, such as gravity. Gravity, of course, is what pulls us down to the earth so we don't go floating off into space. Universal gravitation is the natural force of attraction between any 2 points or any two objects. So here we're talking about a person and the earth, or possibly the earth and the moon. Maybe if you have a pencil in your hand, you and your pencil. With universal gravitation, there are two things that gravity depends on. How strong gravity is depends on these two things. If you look at this equation, we're not going to manipulate this equation, but it does show you the two variables that factors into the strength of gravity. That would be the M of both of the objects and the D. So hopefully you guys know, obviously from our other lessons, that M is mass and D is distance. So the strength of gravity is going to depend on both mass and distance. All right, with weight, when gravity is known, the weight formula is W is equal to mg. You guys should remember at the beginning of the year, I would always tell you guys that weight and mass are different. And the difference here you can clearly see is that we've got this G when we're talking about weight. So hopefully you guys remember that G is gravity. So W stands for weight, M stands for mass, and G stands for gravity. Here on Earth, we use the gravitational acceleration value of 9.81 meters per second squared. That is listed earlier in your notes, but when you are manipulating this equation on some word problems later on, you're going to use that 9.81 meters per second squared. If you forget, just go back and look into your notes. In the metric system, though, for weight, we will not use pounds. What we use is newtons, which is a capital N. Newton's laws of motion. Okay, so the first law of motion is called the law of inertia, and the law of inertia tells us that an object at rest will stay at rest and an object in motion will stay in motion unless acted upon by an outside force. Inertia does depend on an object's ability to resist changes in motion, so it will depend only on the actual mass of an object. So here, when we're thinking about inertia and trying to understand the concept of inertia, you should think about like a mouse and an elephant that maybe are in motion, and you need to think about which one would be harder to stop. So hopefully you guys easily would tell me that the elephant is the one that's going to be harder to stop because the elephant would have a larger mass than the mouse. The second law of motion is called F is equal to ma. F is equal to ma tells us that the net force on an object is proportional to the object's acceleration. So the greater the force that's acting on the object, the greater its acceleration will be. Net force is the sum of all the forces acting on an object, and it must be greater than zero. All right, so here's some examples, some boxes that we can look at. When you look at this, I tell you guys to think about like maybe possibly like tug of war, and that usually will help you to figure out the final answer on these. So the net force of the object on the top box there, you notice that it's going 5 newtons to the left and 5 newtons to the right. So the overall net force would be 0 because that box is not going to move there. All right, on the next one, we have 3 newtons to the left and 5 newtons to the right. So hopefully you're able to see that the net force here is going to be 2 newtons to the right. On the bottom left box, hopefully you see there that looking at all those forces, that our overall net force should be 1 newton up. And on this last box here, after looking at those, you should be able to see that it should be 0 newtons. All right, so which box would have the greatest acceleration? Hopefully this is very easy for you guys to see that it has to be that top right one because it has the largest net force. And which boxes won't accelerate? And of course, that should be the two that have 0 newtons of a net force, so it should be that first and last box. All right, the third law of motion is called action-reaction. For every action, there's an equal and opposite reaction, or for every force, there's an equal and opposite force. 2 objects must be involved in order for Newton's third law to occur. So here's 2 examples. The first example is a bat exerts a force on a ball, and the ball exerts a force back onto the bat. The next example, your weight pushes down on the floor, and of course you know that the floor is pushing back on you. All right, of these laws of motion, here's some examples, and we're going to go through them and try to figure out which law they represent. So the first one says a baseball player hits a softball and a baseball. He's hitting both of the balls with the same amount of force. The baseball has a greater acceleration, though, than the softball. Anytime it's talking about two different masses of things, acceleration, the force being applied, hopefully you'll clue in that that's representative of the second law of motion, that F is equal to ma. Number 2, a bus driver continues moving down the highway at 50 miles per hour until he applies the brake. Hopefully you guys get that is the first law. An object in motion will stay in motion until something stops it. And in this case, it would be him applying those brakes. The third example, a baseball pitcher throws a baseball. The pitcher applies a force on the ball, and the ball also applies a force back on the pitcher's arm. So hopefully you guys see that is the third law, action, reaction. Two objects are involved here. Number 4, a dirty dish is left on the table is still there in the morning. Okay, so hopefully you guys recognize that that's the first law, so that would be an object at rest will stay at rest. Number 5, a skier hits a bump on a mountain and loses his ski, but the ski continues on down the mountain. So nothing is stopping that ski from his motion, so therefore that too is the first law. An object in motion will stay in motion. All right, last 2 examples. Number 6, a baseball player hits 2 baseballs. The first baseball he bunts, so he doesn't hit it with a lot of force. The second one he swings away, so it's out of the ballpark, so therefore he's hit that one with a lot of force. So the second ball ends up having a greater acceleration than the first. Again, hopefully you realize that this is the second law. We are manipulating that equation again, F is equal to ma. Number 7, a kayaker is paddling down the river. His paddle exerts a force on the water, and the water exerts a force on the paddle. Again, our 2 objects here are involved, action, reaction, so that would be the third law of motion.